Assalamualaikum warahmatullahi wabarakatuh. We are from group 5. We are going to present a brief overview of natural language understanding. The first, I will explain the nature of natural language understanding. We begin with an overview of theoretical principle, methodological preference, and strategic choices. The presentation is organized into 4 categories. The first is the nature of NLU or natural language understanding. The second, the knowledge and reasoning needed for NLU. The third, how NLU interact with overall agent cognition. And the last, the strategic preference. The lists are not exhaustive. They are intended to serve a conceptual scaffolding for upcoming discussion. According to Nierenberg and Raskin, language understanding by LEALS involves translating language inputs into ontologically grounded text meaning representation (TMR), which are then stored in agent memory. The primary focus is on the content of the message rather than its form, addressing complexities such as lexical and referential ambiguity. The global interpretation of text meaning is built up progressively from larger groups of words and phrases, with recognition that semantic uncertainty is a natural part of language. Semantic analysis is conducted in stage using a wait-and-see approach, and each interpretation is assigned a confidence level. The importance of acknowledging semantic uncertainty in agent decision-making is emphasized, and confidence levels are used to assist agents in determining their next action. The research focus is specifically on semantic and pragmatic aspects, with pre-semantic analysis outsourced to external engineers. The next is the knowledge and reasoning needed for natural language understanding. Language understanding relies primarily on 3 knowledge resources. The first is the ontology, the second episodic memory, and the last the ontological semantic lexicon. The micro-theories for the treatment of language phenomena, for example, lexical disambiguity, coherence resolution, indirect speech act interpretation, reflect an attempt to operationalize our understanding of how humans make sense of language. Machine learning-based mainstream or NLP doesn't adhere to this objective. We consider listing a good and necessary approach to capturing human knowledge. This includes writing rules, lexicon entries, grammatical construction, and more. And the next, how natural language understanding interact with overall agent cognition. Agents use stored knowledge recorded as TMRs, not natural language text strings, to reason about action, while agents are fundamentally language independent. The process of translating text into TMR remains language specific, although some aspects can be applied across language. Language understanding cannot be separated from the overall cognition of the agent, as the heuristic supporting language comprehension involve the result of processing various modes of perception, reasoning about the speaker's plan and goals, and consideration of the effort required to understand challenging inputs. Like human, agents must be able to employ various reasoning strategies, including language-centric reasoning, analogy-based reasoning, goal-based reasoning, and statistical probability. Models of language understanding that mimic human focus on the connection to action by configuring agents to pursue a level of interpretation that intelligently supports subsequent action. The next is the strategic preference. In the pursuit of developing human-level artificial intelligence, the text conveys strategic preference and the approach used by the research team. Key points include the use of system implementation to test theory and algorithms, the emphasis on an agent's capability for lifelong learning, and the distinction between domain-natural and domain-specific aspects of language understanding. The system development methodology is more task-oriented than method-oriented, focusing on creating natural language understanding capabilities to human abilities. In summary, the team adopts a practical and adaptive approach to achieve comprehensive artificial intelligence goals.
One up example in the simple TMR, for the sentence a gray squirrel at a node. Each element is represented with semantic information. The TMR includes the index one event where the squirrel one is the agent of node foodstuff, one is the temp. The color attribute gray is associated with squirrel one and various relationships. Like agent of and term of are specified, the TMR aims to provide an ontologically grounded representation of the language input. Considering syntactic regularity and resolving lexical ambiguities, the example is straightforward to a single clause, regular syntax, absence of coreference resolution, and manageable lexical ambiguities. The Leia ontology serves as a formal model of the word organized hierarchically with multiple inheritance, featuring approximately 9,000 concepts primarily in the general domain. To maintain efficiency, the ontology follows the principle of minimizing the ratio of knowledge elements to elements in the word as suggested by Hayes 1979. Several factors contribute to the ontology relatively low concept count. The first is synonym mapped to the same ontological concept with nuances captured as constraint in corresponding lexical sense. The second is combination of concepts interpret many lexical items. The third is item representing point or ranges on a scale point to a single property like a different intelligence level like brilliant, smart, pretty, smart, and dumb. The fourth concept aims to cross-linguistic and cross-cultural relevance, avoiding language-specific concepts not universally applicable. And then the lexicon. Leia's lexicon for any language serves to map language element to concept in the ontology, and the defining features of the current English lexicon include: the first is synthetic and semantic description, the second is approximately 30,000 word senses, the third is semantic expression, the fourth is constraint for disambiguation, the fifth is focus on frequent and semantically complex words, and separate coverage of all part of speech, and then inclusion of multi-word expression. And then next is episodic memory. Episodic memory in a Leia is like a record of the things it has said and experienced gathered from language vision, simulation, and its own action. It's a bit like a list of memories, similar to the way we remember events. This memory helps the Leia understand difference, make comparison, and learn new things, while we won't dive deep into it here. Managing this memory involves challenge, like organizing information from different sources and times. For our discussion, think of it as a list of remembered details about various situations. And then the last is incrementally, originally ontological semantic focus on understanding full sentence, like this in formal writing. In the last 15 years, the focus shifted to make AI work better with humans. Now we are more interested in how AI can be used in conversation and dialogue to act more like humans do. Humans often understand language bit by bit, like finishing each other's sentence or starting action before someone finishes talking. For AI agent like Leia, being able to understand language bit by bit is important when it helps them achieve their goals. However, they don't always need to do this thing of it like a tool in their toolbox. Use when it makes sense to do so for better performance.
The next is about the stage of NLU and associated decision making. This type of increased incrementality can more accurately be called horizontal incrementality. Horizontal incrementality occurs when a system processes input words as they appear in the stream of the language being transcribed. Vertical incrementally refers to the depth of analysis applied to each input fragment. In other words, when a system uses language engineering for internet application or LEAA or similar tools, horizontal incrementality is involved in processing words as they occur, while vertical incrementality is concerned with the level of analysis applied to a particular input fragment. As an illustration of this notion of incrementality, consider the following example. The first, a black bear is eating a fish. In this sentence, interpretation occurs directly and is relatively simple. If you hear or read the sentence without looking ahead, there will likely be a consistent interpretation each stage of input. And the example and another example, like my monkey promised he wouldn't do that anymore. This sentence requires more effort to interpret. Monkeys are called because people often call them by the name of an animal. Another example, my monkey promised he wouldn't do that anymore. This sentence requires more effort to interpret. Monkey are called because people often call them by the name of an animal that has characteristics that are relevant in a particular context. This sentence could have been said as a joke about a child swinging dangerously on a seesaw. And another example, like I said the mail just came. This example, when taken out of context, has residual ambiguity regarding the identity of the I and the power of the I said. The latter can be used as an introduction to provide further clarification explanation. And the next, a key aspect of the intelligent agents is their ability to independently determine which resources to leverage and why, as well as what constitutes a sufficient analysis. There are 6 stages of vertical incremental processing. The first is pre-semantic analysis. Pre-semantic analysis covers pre-processing and syntactic parsing. It is carried by an externally developed toolset and includes part of speech staging, morphological analysis, constituent and dependency parsing, and name entity recognition, and decision making after pre-semantic analysis. For example, the agent is a military robot engaged in combat. It works with only one human teammate at a time, so there is no change of topic conversation. The task is maximally high risk and time sensitive. The agent must understand absolutely everything its human teammate says. The agent analyzes each word immediately, horizontal incrementality, and as deeply as possible, vertical incrementality. At the stage of pre-semantic analysis, if any word of input cannot be clearly recognized, for example, like uh, due to background noise, the agent interrupts immediately for clarification. It will be able to fully analyze the nominal compound physician neighbor. For an example, like my physician neighbor came straight over when I called, saying that my dog was bleeding. The compound means human has social role, physician neighbor. More accurate analysis support more correct and more specific new word learning. And the last about situational reasoning. Situational reasoning tries to combine various contextual information, including the agent's understanding of events around him, knowledge of plans and goals, and his interlocutors, and the ability to read the interlocutor's thought. All of this information is used to understand the context more deeply and produce a richer interpretation of the meaning of a statement or situation. And decision making after situational reasoning, for example, the chair making robot. The chair making robot needs to associate many referring expressions in the input that are relevant to it, as in the example that that the the take that hammer and give it to me. The robot must also make such association as it continues the task of determining which input of topic. The fourth is basic conference resolution, the process by which an agent attempts to identify common references of an entity in a text, whether explicitly mentioned or omitted. The agent also reconsider lexical disambiguation and decision making after basic conference resolution. Example like basic semantic analysis was sufficient to generate a full and confident interpretation for some inputs like chair are so easy to build. Basic conference resolution expand the inventory of inputs that are fully and confidently interpreted. For example, if we modify our example to chair our grid, they they are so easy to build. Establishing the conference between chairs and they is all that is needed on top basic semantic analysis to generate a full and confident interpretation. And the next about extended semantic analysis invokes more knowledge base and more reason to improve the semantic or pragmatic analysis of not only individual sentence but also multi-sentence discourse and decisions making after extended semantic analysis. This stage offers many functions to improve such analysis. For example, the agent has method to select the correct meaning of hand. If you see a mechanical clock on the wall and its hands are not moving, trying winding it and resting it, it will be.
The next is golden. Golden annotation in corrupt annotation are considered correct by people either manually created or checked and corrected after automatic annotation. They are crucial for supervised machine learning. A term is called golden the layer correctly used government knowledge based and NLU rules to generate a high quality analysis. And however, time the same input might not always result in the same golden due to ongoing knowledge engineering. And the next is deep dive. Here deep dive have two example. The first is NL, KRL, NL translation. NL is natural language. The NL advantages: people can read both NL input and output. Trained individuals can understand the KRL knowledge base serve as the source for KRL translation. The KRL is suitable for reasoning. KRL reception are language independent, supporting multilingual application. And the second, NL is KRL or KRL is NL. The view influenced by wishing suggests the symbol in KRL ultimately come from NLS and nowhere else as a result. KRLS maintain like feature such as ambiguity, vagueness. This approach aims to make KRLS more NL-like and challenge traditional reasoning technique by stating that automatic reasoning will always be intermediate due to inherent language. And the next material is ontology issue. The key point about intelligent agents is that they can work as well as human without a good understanding of a specific field. It's not realistic to have deep knowledge for every topic stimulationally, just like we can expect a robot to instantly perform thousands of different physical actions. And the next issue of lexicon. Making sure an analysis system doesn't assign meaning to specific text element in certain structure is just crucial as making it capable of assigning meaning. This information is best placed in the lexicon as certain language family often have similar construction. Providing construction sensitive details in the lexicon allows for the reuse of same struct that predict the lack of meaning. And the last is paraphrase in natural language and the ontological metallurgy. Here, another aspect of ontological paraphrasing is word nothing, and the rephrasing that happens when interpreting signal from non-language perception modes. That's all from me. Thank you.